Welcome everyone to the ECG webinar on Broadworks, our quarterly event for Broadworks service providers. Glad to see so many of our friends here in the Broadworks community. And our focus this time is on Broadworks in the cloud. And we are going to be talking about whether that's a good or a bad idea and all of the implications of doing that. So this is a roundtable event. You're going to have an opportunity to speak up and be part of the dialogue, and we hope that you will do that. I know a lot of you service providers do have a good bit of experience on Broadworks in your service provider networks or lab networks, or you're interested in doing that. So who is ECG? We like to say your voice is important. That's the major focus of our engineering thrust. So we do the RFI, RFP, and selection process assistance, helping you pick the right technology to integrate in with your platforms, with your voice and data platforms. We configure networks. We do integration and remediation. So this involves both the voice infrastructure, particularly such as the Broadworks and SBC components and SIP device components, but also the ancillary parts of the network. So that can be load balancers, things like the F5 LTM, the firewalls, the hosting environment, whether that's in data center or cloud or virtualized. We do acceptance testing, including the checking to be sure everything is meeting your product standards. And so we think a lot about whether your product is implemented the way that you desire. We also work on compliance and cybersecurity, and those are particular areas where we collaborate with some law firms here in the United States to ensure that that is done accurately and well, so that we take the legal ramifications and ensure that you're doing the engineering necessary to meet those goals. And we do training and operation support. So we have a 24/7 center that can do operational support for your products, or we help you as you build out your operations team. We do training on all the technology that we work with. And we have quite a few of our clients who are large internet service providers, as well as being voice providers. So some of our clients are listed here across the bottom. I'm proud to have you guys there. And as you can see, we have a mixture of service providers, we have equipment vendors, and then we have public entities. So our special guests today are Tom Faherty, Vice President at Databank. We also have Dave Stewart, who is part of Cisco's BroadWorks engineering team. From ECG, our presenter is going to be Sherwin Crown. He's one of our senior members of technical staff and a vice president. We also have James Puckett on. He's our ECG's president. John Claiborne is another senior member of technical staff, and I am your host, Mark Lindsay. So welcome, Tom, Dave, Sherwin, James, and John. Glad to have you guys here, and we'll get to participate in some dialogue a little bit later on. But thanks for joining us. A special guest is Tom Faherty. He is the Vice President of Network Engineering and Operations at Databank. We're pleased as punch to have Tom here. Tom, tell us what Databank is and about your background with Broadworks.
Sure. Thank you, Mark. Appreciate it. I've worked in service provider environments for probably 25 years now. I've designed and deployed and managed Broadworks-based voice services in a number of these service providers. Happy to say I've partnered with ECG a number of times over my career, including here at Databank. You guys have been an outstanding engineering and operations partner for my teams all along, so I appreciate you inviting me. Quick roll-up for Databank. We're a pretty well-established co-location and managed services provider. We're in roughly 25 U.S. markets, plus the UK and France. Footprint looks like 55 U.S. data centers and 5 spread over the UK and France. 750 folks, 12 years of operations. We're profitable, healthy, all that kind of good stuff. Our bread and butter is carrier grade and neutral data centers. So racks, cabs, cages. For reference, you can think of us as similar to Equinix. Scale-wise, we're in the top 5 here in the U.S. compared to other colo and managed services companies. And we do what you'd expect, right? So rack, power, space, cage, managed internet, managed firewall. We've got a pretty robust private cloud solution. So think compute, storage, DR, but also IaaS and PaaS, which is kind of relevant to this conversation. We have customers who want to virtualize but have dedicated slices for their services. Comes into play quite considerably when we're talking about a Broadworks deployment that a customer might colo with us. So that's kind of us. We're a pretty large data center provider. Happy to be here.
Great, thanks, Tom. We look forward to hearing what you think about this, sort of with your extensive background as it applies here. We're going to go into some top news in the world of Broadworks. So this is where we like to do a roundup of some of what's going on. Our section this week is a little bit on the short side, so we can make some time for our other discussion that we have coming up later. So I'm going to ask John to open us up with some of the news of in Broadworks.
Thanks, Mark. Yeah, so Cisco announced that their product WebEx calling, which is built on the Broadworks platform, on Broadworks technology. It's a core part of NBC's broadcast center for the 2020 Olympic Games that are going on right now. Longtime Broadworks operator AT&T, they announced in June that WebEx calling would be offered to its clients. We're seeing this move as a counterattack to the growth of Zoom calling. And then in July, just last month, Scottsdale-based Broadworks provider Nextiva, they were identified as a leader in the UCaaS space in some reports by the online review firm G2.
Thanks. One of the cool upcoming features I think is really important for Broadworks service providers is this end-to-end encrypted change. They're adding that to push notifications for calls coming from Broadworks. So this is part of their roadmap announcement for October 2021. This will boost the security for call signaling. It simplifies deployment by moving the push notification operation into the application server. And I think it's overall one of the neat new security features that can honestly be overlooked as Broadworks matures over the years. There's numerous new features reported by Cisco for wireless providers. So a lot of growth in the cellular mobile industry among Broadworks providers, enhancing billing and network management there. Lots of features there enabling wireless providers to continue to expand their use of Broadworks. And Cisco continues their monthly Power Hour webinars. We want to recommend those to you. They provide roadmap information on Broadworks product along with integrations with WebEx, which is a major push for a lot of Broadworks service providers as they grow their product line. The next one is coming up August 25. And you can register with those through Cisco. So next, we're going to hear from another special guest, Dave Stewart, who is part of Cisco's Broadworks engineering team, and he's going to tell us about Cisco BroadWorks Cloud Evolution. We are really glad that you were able to join us, Dave. Tell us what's going on.
Thanks, Mark. So yeah, I'll go through, give a view of how BroadWorks is evolving to becoming more cloud friendly, and more integrated into cloud environments. So where we're coming from and where this journey kind of started is in release 22, we introduced the NFM. As part of the NFM, we had the NFI interface, which gave us the ability to plug into an NFV environment to be orchestratable such that we could build out Broadworks servers in an NFV environment. That was enabled essentially through a CX engagement, professional services engagement, to do the integration into whatever NFV environment that a customer might have. We also, in release 22, started the journey into release independent. We introduced the media server, the UVS, the sharing server, and eventually the NFM to become release independent. We kind of view, as you'll see as we move forward, getting into the release independent gets us kind of moving towards a goal of eventual, delivering packaged software as opposed to software patches. And at the end, actually delivering containers as part of our long-term vision. In 2020, as part of release 24, we continued on the RI journey, which is all of the Broadworks servers except for the application server is release independent. We also introduced Ansible playbooks to help manage the RI infrastructure you have in your deployment, such that you don't have to do the Broadworks install, doing the switch context between the releases. You can automate it all through Ansible, so you get a consistent deployment between your integration labs and eventually into your production environments. Also notable in there is that we also introduced AS scaling simplification. That's essentially what we call the network administrator. It gives the ability to have a network admin and an administrator that is privileged across all of your AS clusters in your deployment. And it gives that along with the OCS, the ability to steer OCI transactions based on the target of the transaction, as opposed to the authenticated user, such that back office systems don't necessarily need to know where an enterprise or group or user lives. As long as you use a network administrator, the OCS will steer the transaction to the correct application server cluster. That's hopefully simplifies as your network grows, simplifies your backend, and also operations, gives you a better security posture by having a single admin as opposed to having to manage admins across multiple application server clusters. Okay, then we came into where our vision starts. As far as becoming, making Broadworks more orchestratable, which is a key component needed in a cloud deployment. If anybody's tried to automate anything in BroadWorks, it's not the most pleasant thing to do, having to deal with BroadWorks CLI. One of the first things we'll see in 2022 is an API enablement for all server config, essentially providing it, instead of having to go into the CLI to configure interfaces and some of the basic BroadWorks system configuration, it will all be exposed through an API, a REST API, JSON-based, standards-based API that can be used by pretty much anything. Our vision that we have going forward is that everything we provide for automation out of Cisco would be via Ansible. You'll see a continued us continuing to evolve and add functionality onto our Ansible playbooks. The next thing that's coming out, just as a side note, is the current Ansible playbooks is for managing existing infrastructure. The playbooks that's going to be released in the coming weeks and maybe the next month is the ability to build new servers through Ansible, create a few variables, build a new XSP, build a new ADP, whatever. Also, as part of R24, as I said, all of the servers are RI. We also, as part of that activity, the XSP and PS, the profile server, migrate to a single platform called the ADP, the Application Delivery Platform. That's to simplify deployments. I mean, the profile server and the XSP from a platform perspective are identical. The only difference was the applications that run in them. We always view the profile server to be a core server and the XSP to be a border server. So essentially you have a single server now where you just deploy the applications that you need on there, and then just by the pure function of the application, it'll be either a core server or a border server. Also in 2022, AES will become RI. Timing on that hasn't really been defined yet, but pretty much planning on release 25, AES will be released independent. And that kind of all that evolution up to that point of getting us into everything RI, delivering a single binary instead of having to manage patches, a single release train moving forward, gives us more capabilities and to be able to do server workload containerization, i.e. delivering containers. I mean, our vision would be that applications that run on the ADP would probably be the first that we'd start seeing containers. The ADP would actually migrate from running what we call the Broadworks container to becoming the ADP becoming a container host, whether we're running Kubernetes or whether haven't really decided what the infrastructure will be driven through, but at some point the ADP will migrate to the container host. We'll start delivering, instead of wires that get loaded into Tomcat, we'll start delivering Docker containers. So basically you can go through and actually use Ansible, create your own pipeline, and we're delivering containers on a regular basis to help in that whole cloud deployment. That gives us upgrade elimination. You're basically just replacing containers. And that's kind of the end goal after all this evolution is to get everything onto containers and to simplify the deployment. And the last thing I have on there is the AES multi-data center resiliency. It's essentially having an application server that supports more than 2 nodes. That's a very long-term goal that we have. Don't really have a whole lot of timelines for anything that's in 2022 plus, other than they are in the planning stages.
Great, that's cool stuff. We'll come back and we'll have some time to discuss that and ask some questions later on. So we are going to go to Sherwin Crown. Sherwin Crown is a master's in computer science. He's a senior member of our technical staff and one of ECG's vice presidents. And he's going to be our primary presenter today on this issue of Broadworks in the cloud. About Broadworks, particularly where it stands today, and then the ecosystem around it. So, Sherwin, I'm going to hand over the presenter privilege to you. Sherwin has been doing Broadworks deployments and integrations in a lot of the service providers projects that ECG has been involved with since the mid-2000s. And if you see the Verizon One Talk service, then he was part of the development on that product as well.
All right, thanks, Mark. So So I guess what we're going to talk about a little bit this morning is Broadworks in the cloud, like Marcus talked about. One of the things I wanted to touch on here was just some of our experiences going through the idea of Broadworks in the cloud. And so I think before we go there, I think one of the things that most folks are interested is what are the advantages of actually going to the cloud, right? So we know that the big players like AWS and Microsoft and Google are providing all these services out there. And I think the main reason folks are pushing this direction is because one, it's cost effective, where you don't need to be, paying for a co-location and paying for servers and all that stuff to actually get up and going. You have a fast development time or a deployment time where you can actually sign up for an account and start deploying servers, in a matter of minutes. It's feature packed, where you have all sorts of firewalls and load balancers and DNS services and everything built in here that you can actually use to get your environment up. Highly scalable with its zones and different geo-redundant environments. It's secure and reliable for the most part. And then we get to offload hardware maintenance, right? So we don't have to worry about replacing hard drives or replacing bad memory modules or any of that stuff. And so that makes the cloud an interesting place to actually do your deployments, because most of your IT/server department is basically taken care of by these vendors for you. But when you actually go down this road, I think it's important for us to pay attention to some of the disadvantages that we get in here, right? And that is loss of control over hardware options. So if you were actually engineering your own servers and data centers, you could select the parts and pieces that you wanted in this infrastructure, versus if you're actually using these guys, you get whatever they have. So you're hoping that their stuff is the best, but you don't know because they don't tell you anyway. The other part here is you're going from dedicated hardware resources for your environment, kind of similar to what Tom was just talking about for some of the stuff that he's offering here, to shared hardware resources, right? And making sure that that would be adequate for the real-time operations that you're trying to do with your data set for the Broadworks platform. The other point here is entrusting your data to a third party. So you're actually having your data sitting there, whether it's voicemails or whatever, sitting there on the cloud. So encryption at rest is something that you need to be paying attention to. Make sure your hard drives are encrypted, so forth, because you have to be trusting that these guys won't be leaking your data out there. And then the last one, which we'll cover a little bit later too, is loss of access to layer 2. So this is important for when you're dealing with some redundancy protocols for other devices, not necessarily BroadSoft, but the other components that work with BroadSoft. So some of the hosting considerations for Broadworks-based service provider are like one, CPU capacity. So wherever you're hosting your services, right, you need to make sure that they have enough cores for you to actually support this thing. You need to be paying attention to disk operations per second, right? Make sure that your drives are fast enough to where you can actually handle your logging and your SIP messaging and everything else that's coming through. The same with this throughput, right? You need to make sure you can actually be written to fast enough to capture all your information. Network throughput. I mean, if their network is bottled up, then you're gonna have bad audio quality. Geo redundancy support. You need to make sure your stuff is in different data centers. Fault detection and monitoring. So you need a way to know if your servers are giving issues and get some sort of notification. You have to address it. Out-of-band management and console access. Well, for everybody that runs a data center, you need some way of accessing this if the network interface isn't working. Reliable host uptime. You don't want your services going down in the middle of the day for no reason. Stable network and reachability. Strong security policies, and packet capture capabilities for when you're trying to troubleshoot your customer issues. So I think these are the 11 things that I thought of that we probably would need to at least make sure you're touching if you're building up a new service provider. In terms of Broadworks has their capacity planner. And when you actually input your information in here, you'll notice that some of these values, like your disk throughput and your network bandwidth and your IOPS and stuff, are actually here as well. So you would have to make sure that whatever host you're planning to go with can actually support these values, right? So when you're actually doing the engineering of actually rolling out a Broadworks platform. Now, the question here is, where do providers like AWS and Microsoft and the rest of the folks stand? And the answer is, it generally works well in checking all the boxes, right? So if you're talking about the bandwidth and the throughput and geo-redundancy for your multiple zones and all that stuff, packet capture capabilities, all that stuff they can do. They also have impressive input-output values, like on the right-hand side here, from their EBS volume types. You can see that they have general-purpose SSDs. They're actually pushing, 16,000 IOPS out of these things, and that's on the baseline, right? So, interesting things like that, where you have these specs that are more than met by these providers. But in addition to the great specs, there's also caveats, right? Which is a lot of these cloud providers have, I said poor documentation here, but it's just too much documentation to go through to actually find what you're trying to do. Running a pure your own data center, running your own servers is a lot simpler than doing all that stuff because you know what you're dealing with. Now, obviously, you can find the information, and after that, you figure out how this thing works and is put together. It's a lot easier to replicate again. But the first instance you're going through this, it takes longer to pull this off. There are also resource limits, and by that I meant that, like the types of images that you can use, the volume sizes, number of snapshots, those things are limited based on the regions that you deploy these things in. You can find some images in the US and not in China or wherever you're trying to deploy your stuff. So you need to take that into consideration there. It's not an infinite number of these things. And then reachability. So from my personal experience dealing with these things, I have run into issues where I could not connect to a machine. So, you would try to SSH into the box and the box would be unresponsive. And the only way to get into this box is to go reboot the thing. The console access wasn't much help there either. So you need to take into consideration that there might be some issues that would go on with your VM, and you have to make sure that your platform is really redundant. So that if there is a blurb that happens on the network here, that you can actually recover without causing customer impacts. And then also, I mentioned that before, which is the lack of layer 2 access, which would be needed for other components, non-Broadworks components. Now, I put this slide here to specify Cisco's latest supported, which a keyword there, supported cloud model. Now, this is in their Amazon Web Services Deployment Guide, and this is the latest one I found on Exchange recently, which is stated there for July 30th, 2020, which they actually recommend a hybrid model where you would have all of your messaging servers, like the app server, network server, profile server, UMS, USS, XSPs, VBS, those can be in the cloud, whether it's Amazon or Microsoft, whatever. And then what they recommend is that you would have your SBCs, media servers, video servers, WebRTC servers in a customer provided network, which is something not the cloud, with some sort of VPN tunnel connecting the two. So obviously there are some service providers, like we talked about earlier, that have their entire infrastructure in the cloud. I don't know if BroadSoft's stance has changed since July 2020, but this is the last I've seen that they stated that is the supported model. But just to be aware that that's out there. So the question here that a lot of people ask is deploying Broadworks in the cloud any different? And for Broadworks servers, the answer is no, not really. The same process that you would do on any regular data center servers, which is the install, server preparation, configuration, is all the same. And that's because the Broadworks servers are layer 3 friendly, right? So they're designed to work on all layer 3 protocols. And so when you're dealing with AWS and these other cloud providers, they work perfectly fine. So the caveat here that people have to pay attention to, which I ran into the first time I tried deploying stuff in the cloud, was that all of my servers, the licensing for all of my servers were working fine until I got to the XSPs and the profile server, and then it wouldn't accept my licensing at all without an NFM present. And so you got to pay attention to NFM is not free and it costs money. So there's an additional cost to actually get that going in there. So it was a little inconsistent on whether or not a license was required, or an NFM was required, sorry, for licensing. So the other part of this is, what about the other peripherals around the Broadworks platform, right? So we know Broadworks are layer 3 friendly. We know that's going to work fine in the cloud. But what about the SBCs, load balancers, firewalls, and those things? And the answer to that too is it will work fairly well, but it lacks the layer 2 connectivity that we talked about, right? Which means a different and failover processes. So we know that some of the leading SBCs are built to expect layer 2 connectivity in there, and you don't necessarily have that. So your redundancy is a little different. And so, vendors are coming up with different solutions, which is a layer 3 based solution to solve this using watchers and so forth. But until that actually gets rolled out properly, you need to be sure that, that is a slight difference that you have to pay attention to. So the other part is, what about Terraform and Ansible in cloud deployments? And, we just heard a little while ago that, folks at BroadSoft are using Ansible extensively. Now, they also have their Terraform scripts, which is an infrastructure automation tool, right? So I think both of these tools are very useful. I think they are very good for, well, Terraform in particular, very good for standing up new infrastructures. But I think it's if you already have, it's good for the first use from my experience. I wouldn't necessarily be using it multiple times. So investing in that in the Terraform code, if you're just a single service provider, might be, I don't know if it's worth the time. I'm trying to say. Now, in terms of Ansible, I think Ansible, being that it's it's doing a configuration management, I think where Ansible shines the most is in application deployment, and so you can do downloads, installs, deploy, configurations, all that stuff with Ansible, like what we just talked about in a previous presentation. So in a day-to-day environment, I think Ansible would be more useful for most people. But those are the contrast of two. So Terraform is for building out the infrastructure, and the VMs. Ansible is for configuration and deployment of the applications on said VMs. So new issues deploying BroadWorks in the cloud. This is compared to data center bare metal stuff. I mean, this is just a summary of the stuff that we found, which is one, NFM requires money for the cloud, which I mentioned for the XSPs and the profile server when I tried it on release 23. The Terraform scripts, the ones provided by Cisco BroadSoft, when we tried it, it wasn't mature enough. It didn't work consistently all the time. Now, maybe it had gotten better since then because it was a while ago. But when we tried it, we as an ECG tried it, it gave some issues. The SBC failover complications for layer 2. Database synchronization is another thing. What we're talking about here is high latency. If you're doing geographic locations, different countries or whatever you're going to do, you're adding latency, right? And so there is a minimum response time that's required, a round trip time that's required for database synchronization to work properly. So you got to take that into account. And you also got to take into account the regional privacy laws, where your data lives and how you're going to handle that, encryption at rest, all that fun stuff. And then you need to deal with careful consideration of your media server policies, which is, to keep the media streams in region if possible. If not, you're going to try to send stuff all over the place, which, you're causing issues unnecessarily.
Great. Thanks for that, Sherwin. We're going to go to some discussion time. And in particular, one of our partners that we work with, Evolve IP, is a major BroadWorks service provider, some of the largest operations of some kind. And Shannon Detweiler leads engineering on that network, and she's with us. So Shannon, tell us about your experience with this topic.
So I would say most of my experience kind of echoes what Sherwin said. We did a R21 SP1 stack out of Amazon. I would say it was about 2-3 years ago now, and we ran into the same things. We had to have an NFM. One thing I will say for the NFM, you do need to have an NFM per NS cluster you have. So that's, it increases your cost if you do have multiple NS clusters.
Yes, we have multiple labs, so that's definitely a thing.
Yeah. Another thing that we ran into, everybody knows that BroadWorks alarms can be very verbose when they are interrupted in their communication. We had a lot of issues with the connection with Amazon's network. Obviously, Evolve IP is located in the US, primarily where we were starting with this and expanding our cluster to London. What we found out is, the connectivity just wasn't that great. We would get alarms, I would say a couple times a month, maybe once a week. And you would just see, oh, we lost the entire stack out in London. Obviously, we kind of knew what it was. We fix it, go on with our day. Another couple things that we kind of saw, obviously echoing the issue with the hyperscalers and the SBC hiding of layer 2. So we did have SBCs, and we saw, you have to use it like geographic redundancy. There was downtime, nothing failed over quickly like it does when you're in your data center. Another thing, that we were warned about was database synchronization times, because we were doing it over such a widespread region at that point. We didn't really see a lot of issues there. We were, crossing, and we had the network server cluster crossing from the US to London. We didn't really see an issue. There wasn't a lot going on in London. We never really built out the cluster before we ended up tearing it down in favor of we acquired a company with local presence. So we moved into that data center instead. But before we did that, we didn't really have an issue with any of the synchronization times, even though it was a warning we received. Let's see. Oh, and then the other concern, obviously, is GDPR. So we did have our media servers in AWS. We had no issue with that. We did the media servers, the voicemail servers, and the call recording servers. We're all virtual, all existed within AWS, and we had policies that would keep our local audio and media stuff all local to that region. Yeah, I mean, honestly, the rest just echoes exactly what Sherwin pointed out already.
Yeah, that's good. That's good real world implementation data, Shannon. Thanks for sharing that. We'll open up the mics for anyone who wants to contribute to the discussion here in just a minute. But let me invite our panel here, Dave and James and John. If you guys have any feedback or questions, anything you want to echo from what Sherwin said.
Is that something that you guys are still saying? No, it probably needs to be on bare metal and that sort of thing, or are you guys moving towards more public cloud type stuff?
The question was kind of quiet, but I think the question was, we had documented limitations in public cloud on like the media servers.
Right.
We have since changed our stance on that. Because we support the media servers in the public clouds now. With the same limitations as if it was virtualized. We consider it the same capacity as a virtualized media server.
Great.
Is that the 1,000 ports limitation? Is that what we're referring to?
I believe that's what it is.
Which
Cool.
I think
Okay.
makes perfect sense. It seemed like if you could do it in VMware, you probably could do it in AWS or any other public cloud environment. I think for everybody, and it's probably obvious at this point, considering how we've, but when we talk about cloud, I mean, if you're a Broadworks provider, you've been the cloud for 20 years now. When we're, at least for the point of this presentation, I think we're mostly talking about the cloud from a public cloud provider perspective, AWS and Azure and, those sorts of things. Not necessarily, your cloud server in your VMware in your data center, which is still somebody's cloud somewhere.
Yeah, and that kind of makes sense, right? There are a number of components that can behave well in virtualized environments from a Broadworks perspective, and there are some that you maybe don't want to do that for, especially at scale and volume. Depends on what you're trying to support, how many endpoints you're trying to support, all that good stuff. I think there's a pretty good argument to be made for SBCs should not be virtualized, but there's rules to bend there too, depending on what your application and your volume is. There,
Right.
James, your point on public cloud is right on, but there are some people that would consider private cloud, right? You stand up an IaaS or PaaS infrastructure. That has a vastly different performance and response profile than a public cloud like Amazon or Azure. So there's a couple of mixes here, right? We just kicked this whole thing off with, hey, cloud, but there's really two flavors, right? Pub and then private, and you can get private from a lot of people. We're one of the folks that provide it, but the point is, it sort of depends on the scale and the kind of response time you're trying to provide the end users, what your choice would be.
Right.
I was interested to dig in a little bit more on the SBC in the cloud part. And so, if we have an on-premise SBC, oftentimes we'll have two chassis that are doing HA over layer 2, and it's talked about a little bit. And so that's the redundancy to guard against a chassis failure, hard drive failure, whatever. we've moved that to the cloud. Then for that, we're relying on AWS or whatever to have chassis redundancy built into their compute platform that's offering those resources to us. And then, like you guys have talked about, it becomes more geographic redundancy where the endpoints are then figuring out that a particular SBC site is down, and then the endpoints themselves are moving around. And Shannon, you mentioned that that's slower. And in you guys' experience, how bad of a trade-off is that? How often does one of those SBCs go unavailable, and how bad of a trade-off is that? I think is my question.
We didn't see it fail over often. It really came to be an issue, during a maintenance window when we needed to upgrade the equipment, and obviously couldn't fail over cleanly at that point. So it was, we just had to notify about it. I think the system itself was pretty stable outside of maintenance windows, though.
Gotcha. So that every time you want to upgrade, that becomes, we don't have HA to make it nice and smooth. And yeah.
Mm-hmm.
It probably changes your maintenance procedures. Like, I mean, certainly we've got service providers that are very, sort of large, but without tons of overhead. And even in those cases, sort of during a maintenance window, the idea of failing over, call it 30,000 endpoints to another data center, it just wasn't terribly appealing. So you end up adjusting your maintenance procedures to use things like DNS and whatnot to move things around. So I think from a maintenance perspective, you could probably work around that. But I really do hope that some of the SBC providers come to soon realize that sort of a layer 3 failover solution, layer 3 heart beating, or third-party watcher, something will help with that failover process. But until then, it is sort of a little bit painful.
Yeah, I totally agree with that. I can remember back in the day when we used Acme Packet SBCs and they told you not to geo separate them, but we got away with it with low latency links between, but still within the same general geo, at least 2 different facilities. I mean, it's something that's gone unaddressed for quite a while.
Yeah, dark fiber across the river is an expensive way to get there.
Straight. Less expensive these days.
Yeah, but one of the interesting things there, like in that scenario that you brought up, Tom, was you have to be able to bring the same public or client-facing IP address to the untrusted access interface of both of your session border controllers at both sites. So if you're, the public IP address is 4.1.2.3 on, your Secaucus, New Jersey data center installation, then it's got to be 4.1.2.3 on the Manhattan data center, and you got to be able to bring that there. So through routing, you've got to be able to do that. And I wonder I can imagine where private cloud providers might be in a better position to be able to do that.
Yeah.
But that's really the same kind of layer 2 synchronization problem. Kind of just we've moved it. Even if you can move it away from the synchronization links, you've got to move it to those front side VLANs. If you can't really share subnets in these public cloud providers, then we're really going to need to have some other option, like a load balancer that's able to distribute traffic, but do it with SIP rather than do it with just by distributing the IP subnet across 2 different physical data centers. You can do certain things in data centers. You can probably do certain things in private cloud that you probably will never be able to do in public cloud. That seems like such a niche application. And it has something to do, I think, with the fact that there's such a small market for SIP-like applications for these public cloud data centers that they're not interested in providing a function, a network distribution function where you have one big Ethernet subnet that's distributed across multiple, AWS regions, for example. They're never going to build that. So it feels to me like what we really need has already been said a couple of times, but we kind of need the SBC vendors to step up here and provide some additional innovation. Yeah.
Yeah, absolutely. I would agree with that 100%. And, public cloud providers are not interested in providing what you're talking about because they'll be on the hook for the service response, the performance of that. Whether or not they offer an explicit SBC option, which they're not going to do. They're going to give you the underlying container and tell you to go. They don't want the problem that's going to come from trying to implement that on the infrastructure.
Right.
And so it's crazy because what are we, 15 years into VoIP? I mean, serious VoIP that's enterprise capable. more so in the last 7 to 10 years. But the point being, like, SBCs need to catch up because they're a part of this equation that is everything, and they're slow to come around to address the way the market would want to adopt it and get resiliency and redundancy and all that stuff. I mean, I think it's a great call out.
And even so, there's another point I'll throw in, which is, there's some innovation that could happen on the SIP endpoints that we're not seeing. So, for example, there's the SIP outbound standard, which would allow a phone to effectively send registrations to 2 different SBCs and do some, so you can configure it to build the redundancy somewhere else. And so that's another option. You still can't buy that. I mean, you can build that in your own soft client.
Yep.
You see companies like Ring Central who do innovation around that space on a soft client that they develop themselves. But among the sort of the generally available soft clients and SIP phones, like we just don't have the tools to do a really smooth failover. And so there's more than one way to solve this problem. And I'd like to see the SIP endpoint vendors also dig in here.
Yeah,
well, and I suspect, and Dave may have a thought here, but I suspect the folks that are using WebEx and WebEx calling, they're in the WebEx folks are in a great position to be able to sort of solve that problem if you're willing to be focused on a WebEx client endpoint. I don't know exactly how that failover exactly works in the cloud for WebEx clients, but certainly this is a problem that if they haven't solved already, that they could solve in their dedicated client.
It feels like there's opportunity to push to cloud. Let's just call it public cloud for a second, because there is a difference between private and public, as we've discussed. There's an opportunity to push some components of a Broadworks deployment to the cloud, but not all. And there's a pretty good argument to be made for keep your SBCs out of that and keep some other key systems out of that too. I think it's a hybrid is what we're looking at right now based on what's available, what we can control, and the kind of performance that you can get guarantees on from public cloud versus however else you solve the other side, bare metal, IaaS, PaaS, whatever. It's kind of a mix, and you'd probably have to ask yourself, how much cost savings do I have? And flexibility, putting stuff up in public cloud, because you're going to have to pay for the resources, pay for the bandwidth. Is that better than you defining your own colo footprint somewhere and distributing your assets in a way that gets you resiliency? You're going to pay for it no matter what. And I feel like there's only a handful of components that really live well in a Broadworks environment in the public cloud. It gets a little bit more forgiving if you got private. I'm just suggesting.
I don't disagree. I don't disagree, Tom. I think though, we focus so far on the layer 2 failover of the SBCs, and certainly when you have a hybrid scenario as you're proposing, which has been the sort of state of the art for the past, sort of 5, 6, 7 years.
Yeah.
Then it's a different set of challenges when you go the hybrid route. Like you still need some technology to connect the SBC, backside of the SBC, whatever, to Amazon, to Azure, to the Google Compute platforms, that sort of stuff. And it's those, it's hard. It's just that they do not make it cheap and easy. You can go either route. Like you can go the easy route. You just put in a dedicated dedicated private link, which Amazon's happy to charge you to connect to. Or you can go the hard route with, IPsec tunnels and, all the other crazy VPN stuff. Or, we've tried some of the newer, VPN-ish technologies, and, the various SDN stuff. And I don't know, that complexity of the hybrid cloud sort of, I don't know, it feels to me like you either got to get happy with putting it in a data center on, bare metal hardware, be it, co-located with somebody like Databank or in AWS, and get happy with some of those limitations and build your service around that. I'm still a little bit apprehensive about the hybrid approach. So, That anyway, that's a personal feeling. I would be interested to hear if anybody else is, Tom, Dave, and any of our other guests have a
If
thought
I
on that.
if I could throw this out for maybe 20 seconds, James, actually mostly agree with you there. I feel like a mix of bare metal and maybe private cloud makes some sense. Public cloud could too, but your point here is how do you reach that? VPNs are garbage for this, man. Absolutely. So you look to a data center provider that you might put your bare metal or private cloud with, and then you still want to reach Amazon and Azure. How do you do that? And there's a good solution for that these days. We happen to be working on it with them. Packet Fabric, PCCW. They've got on-ramps, Amazon East, Amazon West, Azure East, Azure West. Those are controlled circuits, guaranteed throughput with SLAs. Customer doesn't have to pick, and anybody can do this. Any co-location provider can do this as long as they got a relationship. The point is, those guys have a pretty well controlled national backbone with reservations and quality of service guarantees. You can get an on-ramp up to, let's say, Azure or Amazon through one of those guys. And that takes out the requirement of doing VPN or the customer requirement of, hey, I got to build something to a hyperscaler. And we all know that Microsoft doesn't want to hear small company doing a direct interconnection. They want to hand it off, right? So let's angle for Amazon for a second. You can reach those guys via Packet Fabric or PCCW. PCCW is making a huge push in the US right now. They're building out, just like Packet Fabric has, interconnection hubs where you can, take a link from them and then provision, once that link is established, provision on the fly, almost in real time. It's amazing. We're doing it. It's our vision. Our interconnect vision is to do what Packet and PCCW do. And until we have it on our own, we're partnering with them. But for any provider that wants to do business in an Equinix facility or even our facilities, we have these guys. So you can get a pipe to the hyperscaler, which gives you that dedicated, if you will, low latency connection, SLA that you need to back up the kind of customer-facing SLAs you provide. That's an option. Going over public internet and using VPN tunnels to reach cloud, maybe that works for really low-end stuff, but if you're serious, if you're looking for toll grade, you need that confidence of a dedicated pipe. And we are very friendly and fans of both Packet Fabric and PCCW.
Yeah.
Tom, thanks for that. That's an interesting point. It's interesting also on the PCCW operates a Broadworks system. Let me open it up to anyone else if you'd like to go off mute, use your camera if you'd like to, and join the conversation. We'll give you a chance right now. We'll take a minute. Anyone who wants to pitch in a question or comment, feel free. We got one question I'll read to the panel here. Can DNS technology be used to help eliminate the temptation to do SBC failover between cloud data centers and clusters at layer 2? And I think, James, this might have been something you kind of already touched on, but it sounds like the idea here is using DNS to avoid having to design your SBCs to require to do failover in the sort of the conventional layer 2 way, using multiple SBCs instead of just one. Can you say anything more about that?
I mean, I think it could be done. It's going to require client support, and I don't know of any clients that do this. I do know that Metaswitch back in the day, and they may still have the product, I don't know. They were doing some sort of session read connect thing. It was designed to solve the problem, failing over between packet data and Wi-Fi back and forth and that sort of thing without having to, restart the call. Certainly it can be done. I don't know anybody. So much of what we'd really like to innovate on requires client-side support. And unfortunately, the current client-side vendors, they seem to be reticent to take up any sort of non-standardized sort of solutions to these problems. And you know, they're just without the client side support, it seems so incredibly hard to get that done.
Yeah, actually, I'm going to make a pitch here that it is. I mean, you say you're right. You don't want to like take non-standardized things, but there is an RFC 5626 that actually talks about this. So this has actually already been thought through. You know, this came out in 2009, so this has been thought through. We just haven't seen a lot of uptake on this where you can do it. It's not, you know, just because something's published in an RFC doesn't make it perfect. But you know, I'd love to see the client-side vendors do this. But really, it takes service providers who say, "Look, vendors, we want to buy your phones, but this is really what we need from you. We need this one new protocol support." And we've seen that make a difference at service providers before, for sure. But yeah, I put that RFC up there, 5626, just simply because, you know, it doesn't take a lot of imagination to at least start there by implementing an RFC.